In first video of electric circuit, we discuss about the basics of the electric circuit, Ohm's law, KCL, KVL, and Wheatstone bridge. Now in this video, we will discuss few problems based on those concepts, so that our clarity will be there about those concepts. So here, first problem I have, that's effective resistance. We have to find the effective resistance between A and B in the given circuit, and we have three resistors, 6 ohm, each of 6 ohm resistance. Now how to find the effective resistance? See here, it's very easy problem. Here point A and point B, between that we have to find the R equivalent, and we can say that here point A having potential VA, and because this is the wire, will have the same potential at every point, so here also the potential will be VA. Okay, now here if I will consider the potential is VB at point B, so because this is the wire, the same potential at every point, so here also the potential VB. One thing you should keep in mind that when wire is there is no resistor, it means that there is no drop. So if VA is there is no drop, so same potential everywhere, so here also the potential is VA. Same thing is happening here. Now here the two potential points are only here, VA and VB. We are not finding any third potential point, so we will redraw this again. Here we will write VA one point and another is VB. Now all resistors between these three potential points only. So first 6 ohm is here only, so we will draw this, redraw this. 6 ohm, again 6 ohm, and again 6 ohm. So these all three resistors are between two potentials, V and VB, common potential, and so this is in parallel connection. So what will be the R equivalent? So R equivalent will be, because each resistor having same resistance, so it will be simply we can write R by N. This is what 6 by 3, that is what 2 ohm. So answer is 2 ohm. You can solve by 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3 is the same answer you will get. So the answer is 2 ohm. We will go for the next problem. Next problem. So what we have to do here, we have to find the effective resistance between A and B. So here between A and B we have to find the effective resistance. So what we have to do in this type of problem, see here, this is what repeating 2 3 2, then 2 3 2, then 2 2 2. Okay, now here it is 2 2 2. Now whenever this type of problems are there, we should start from last. So starting point, last we should start. So see here, when current is current is coming from this point, then it's divided, then current is again divided here. But this current, see here, the current that is coming out from the 2 ohm will go in the 2 ohm, again the current coming out from the 2 ohm will go in this 2 ohm. So as I discussed in last class, that if this type of scenario is there, we should take those resistors in a series connection. So here 2 ohm, 2 ohm, 2 ohm will be in series connection. So series connection, it will be 6 ohm. Then 6 ohm, I will redraw this. Here we can write 2 ohm, 3 ohm, 2 ohm, again 2 ohm, 3 ohm, and this is 2 ohm, then 2 2 2 6 ohm, and this will be parallel to this resistance. There 6 ohm it is. Now here 3 ohm, this is 2 ohm and 2 ohm, now 2 ohm, 3 ohm. I will rewrite this, and this is point A and point B. Now see here, again now here always we should start from the last. So 6 and 3 are in parallel, so 6 3 parallel. So what is the R equivalent of this 2? 6 into 3 divided by 6 plus 3, that is what 18 by 9, that is what 2 ohm. So in place of this two resistor I can put what 2 ohm here. So finally what we will write, I will redraw this again. I can redraw like this. So here we can redraw, this is what 2 ohm, 3 ohm, this is 2 ohm, and here it is 2 ohm again, and this is what we have done already, it is 2 ohm, and this is 2 ohm. what you're getting again, now see here, the current will divide here, and the same current is going in this 3 resistors. So these 3 resistors are in series connection, so it will be 2 plus 2 plus 2, that is what 6 ohm again, and then 6 ohm will be parallel to 3 ohm. So same thing is repeating again. So simply we can say the answer without solving this much. It will be finally it will be 6 ohm, R equivalent will be 6 ohm. So you can do it here. What we'll do, see here, so here I will redraw this again. So here 6 ohm, then 6 ohm will be parallel to 3 ohm. So I will redraw this again. So see here, this is what 2 ohm, then here 3 ohm, and then here it is again 2 ohm, then this is what 6 ohm. The same thing is again, that is what 2 ohm. Then finally we can write in place of this 2, we can write again 2 ohm, R equivalent of this 2 ohm. Then finally it is 2 ohm, 2 ohm, and then 2 ohm. So answer is final R equivalent between A and B. The answer is R equivalent is 2 plus 2 plus 2. This is the 6. The answer is 6. So easy problem. Only you have to see whenever this type of problem, the last you should start, and then you will continue that. You will get the final answer. We'll go for the next problem. So see here, we have a problem of Wheatstone bridge. So in this problem, you can see there is a Wheatstone bridge, and in this circuit shown in the figure, the value of resistance X here, X resistor is there. You have to find this value when the potential difference between B and D is 0. See, this point B and between point D, the potential difference is 0. So this is the case of what? Balanced Wheatstone bridge. In balanced Wheatstone bridge, there is no potential difference between these 2 points, so that no current will flow between these 2 points. Okay. So what is the condition for balanced Wheatstone bridge? 21 into 6 equals to this resistance, the effective resistance this side, into 18. Okay, so first we will find what is the effective resistance between B and C point, So see here, these are 2 are in parallel, so we can write here it is 8 into X divided by 8 plus X, because both are in parallel, R1 1 by R1 plus 1 by R2, R1 R2 by R1 plus R2, and this is in series with this 3 ohm, so plus 3 ohm. Okay, so we got the equivalent resistance between B and C. Now as it is a balanced Wheatstone bridge, so in balanced Wheatstone bridge, what we have to do, we have to take the balanced Wheatstone bridge condition. So what is that condition? The condition is this, like this is R1, this is the R2, this is R3, then R4. So condition for balanced Wheatstone bridge is R1 R3 equals to R2 R4. Okay, so R1 is what? 21 ohm into this value, that is what? 8 into X divided by 8 plus X plus 3. Okay, equals to what? Equals to here sorry, here R3, it is R3. So here this is, we can do here into R3. What is R3? R3 is here, this one, 6 equals to this value, 8 into X divided by 8 plus X plus 3 into what? Into R4, that is what? 18. Okay, when we solve here, we'll find the value of X. So we have to find the value of X. It's very easy problem. You have to just solve this, and after that you will get the X value. Okay, so we'll go for the next problem. So the next problem is, here we have to find the effective resistance between the point A and B. This is point A and B. So we have done this type of problem, but that time there were no resistor, there were only wire. So potential were same between the points. Here resistor is there, so no, there will be no common potential. So what will we do? See here. Here potential is VA. Here let VB. Okay. So here you take VC, and here VD. Okay, A, B, C, D also you can take the points. So here point A, point you just draw it in form of regular Wheatstone base A, and then B, here you draw B, then C, and then D. So between A and C there is one resistance between A and C. So yeah, one resistor is there. See here, between A and C one resistor R is there. So between C and D again one resistor is there between C and D. So here between C and D one resistor is there. Okay, same way between D and B, between D and B another resistor is there. Okay, same way what can we say, between D and A, between D and A another one resistor is there. Okay, D and A, C and B, any resistor is there? C and B, yes, this resistor is there. So we will write this one also. Okay, the values are R. The 5 resistor, and the combination of 5 resistor is what? Balanced, sorry, Wheatstone base. And if the condition followed, like here R into R square, R into R square. So this is following the case of balanced Wheatstone base. So this is what? Balanced Wheatstone base. So here you can remove this because the potential C and D is what? Same only. So there is no current flow. When there is no current flow, there is no use of this resistor. We will remove this. So now what is the R equivalent between A and B? So this is A, this is B. So here these two will be in series if you will remove this. Okay. So R and R, 2R. So finally you can write this one because these two in series. Now here the same current is going in these two. Okay, you remove this one. Okay, so that's what 2R, and then again this is series, that is what 2R. These two will be in parallel. So 2R in parallel, so R equivalent will be what? 2R by 2, because two same resistance. When two same resistance in parallel, the R equivalent is R by N. So here N, two resistors are there, so 2 we can write R equivalent will be R. And you can use the simple formula, that is 1 by R equivalent equals to 1 by R1 plus 1 by R2. So same thing you will get. So this is the case whenever you have a problem of Wheatstone base, be careful. Okay, so you should understand that Wheatstone base combination of 5 resistors. So whenever you are seeing that 5 resistors are there, whatever the shape it is, you try to bring in the simple form and then you solve it, you will get the answer. Now next we will go. So here we have to find the current through 10 ohm resistor. We have to find the current through 10 ohm resistor in the figure is approximately equals to what? So how to find? We can use the KCL as we discussed already. KCL is Kirchhoff's current law. So what we'll do? See here junction is this one. This is the junction. So let here junction potential is X, I will take. Okay, junction potential is X. Now I will use the junction rule. What is the junction rule? KCL rule. Sum of the outgoing currents from any junction equals to 0. I discussed in last class. It is what? At any junction in electric circuit, the input currents equals to sum of the input currents equals to sum of output currents. Same thing you can write that sum of the output current, sum of the all output currents from any junction equals to 0. So here we will write at junction X, we will apply the KCL. So what will be the final answer? We can write we will write first equation X minus 10. Potential difference, because I equals to V by R. V is potential difference between the points where the current is flowing. So X minus 10 divided by resistance is R, I equals to V by R, plus X minus 7 divided by 20 plus X minus 5 divided by 30 equals to 0. Okay. So here the R value is Here R value is x minus 10, R value is 10. Okay, we have to find the x value, and what we have to find? We have to find the current through 10 ohm resistor. First our objective is to find the x value. So we'll solve this. So what is the LCM of this? LCM is 60. Okay, so here 6x minus 6x minus 60. Okay, then here it is what, plus 3x minus 21. Okay, then plus 2x minus 10 equals to 0. Once you check the calculation, the LCM is 60. 6x minus 60, then 3x minus 21. Okay, then 2x minus 10. Correct. Okay, so we will continue this calculation. Once after doing the calculation, you will get the answer. 2 minutes. Okay, so see here after the calculation, 6x, 3x, 9x, and then 2x, 11x. So it will be 11x, then here minus 10. See, 60, 70, 80, 81, then 91. So here x equals to what? Here, that is what, 91. Once you check the calculation, 60, 70, 80, 10, 90, 91. Okay, then here x is 91 by 11. 91 by 11. So once you get the x value, see the calculation once. Okay, so once you get the x value, you have to find the electric current through what? You have to find the electric current through this 10 ohm resistor. So what is the electric current through this 10 ohm resistor? So electric current through 10 ohm resistor is I through 10 ohm. Like this is I. So I, the potential difference here, 10 minus x divided by, because drop is happening after 10 ohm, the potential drop will be happen. So x, 10 minus x divided by 10. This is the electric current to 10 ohm resistor. That's, you can write 10 minus x value, 10 minus 91 by 11. X value will put here. Finally 10 minus 91 by 11 divided by 10. When you will solve, you will get the answer. So answer will be almost, it will be 0.172 ampere. So I think so I have discussed the types of problem in electric circuits. So you have, I think so, after this video, basic idea about how